Hello everyone, my name is Dhanush BS. I am pursuing my first year engineering in Computer Science and Cybersecurity in Sri Venkateshwara College of Engineering. So today's topic is corrosion and reactions. So the introduction to corrosion. The word corrosion is derived from the Latin word called corroder. Several metals undergo corrosion when exposed to air, water, or other substances. A typical example of corrosion is the rusting of iron. Definition of corrosion: the destruction of metals or alloys by the surrounding environment through chemical or electrochemical changes is defined as corrosion. So the primary factor that initiate corrosion of metals are atmospheric air and water. So metals, being good conductor, undergo electrochemical changes on the surfaces. So these changes are carried throughout the objects and the entire metal gets destroyed. So this is about the definition of corrosion. So let's see about the types of corrosion. So there are two main different types of corrosion. The first one is differential metal corrosion and the second one is differential aeration corrosion. So differential metal corrosion. So differential metal corrosion is defined as when two dissimilar metals are in contact with each other, the differential metal corrosion occurs. So differential aeration corrosion occurs due to the difference in concentration of air over the surface of metal. So let's see the summary of differential metal corrosion. So it is also known as the galvanic corrosion or bimetallic corrosion. So in this electrochemical process, one of the metal acts as anode and corrodes more rapidly, while the other metal acts as cathode and remains relatively unaffected. So the rate of corrosion depends mainly in the difference of potential. So the example of differential metal corrosion is when the iron is in contact with copper becomes anodic and undergo corrosion. So whereas copper as cathodic remains constant. So this is all about the differential metal corrosion. So let's see about differential aeration corrosion. So a differential aeration corrosion is a type of corrosion that occurs when different areas of metal surface are exposed to air. So the non-uniform exposure to oxygen creates an electrochemical potential difference between region of the metal surface. So the example of differential aeration corrosion is the part of nail inside wall undergo corrosion and the partially filled iron or steel water tank. So typical example of this corrosion are waterline corrosion and pitting corrosion. Let's see about corrosion control methods. So corrosion can be controlled preventing the formation of galvanic cells on the surface of the metals. There are many methods of controlling corrosion, but for now we shall detailedly go under protecting coating. So this method is used to apply a protective layer of coating to the surface of an object or material to prevent from being damaged due to various environment factors such as corrosion, wear and tear, exposure to the chemicals, moisture, or other adverse conditions. The primary purpose of the protecting coating is to extend the lifespan of the objects and materials to improve the appearance and the functionality of the objects and materials. So this is again classified into two types, that is inorganic coating and the metal coating. Let's see about corrosion penetration rate. The corrosion penetration rate is also shortly called as CPR. The corrosion penetration rate is the speed at which any metal or alloy loses in specific corrosive environment through chemical or electrochemical reactions. So the amount of weight lost per year in the thickness of metal or alloy due to corrosion depends on the factors such as nature of metal, nature of environment, and the nature of product. So this is all about corrosion penetration rate. The formula of corrosion penetration rate is CPR is equal to K into W divided by P into A into T in MPY or MMPY, whereas W indicates the weight loss of metal, T indicates the time taken for loss of metal, Rho indicates the density of metal, A indicates the surface area of the metal, and K indicates the constant. So this is the formula to calculate the CPR.